morning. My name is Sayfan Borghini. I come actually from a background of science, of systems and complex systems. What I'm going to speak about now is to unpack a bit this concept of complex system and to correlate it to a number of systems that we all know, to see the workings and the mechanism, and then to come back to the urban context.
Yeah, just a second. I just want to make some sort of framing here that we are, Sayfan is going to present the mechanisms and the patterns of complex systems, and then afterwards in the workshop we are going to work with them. So in this session, I will take the time in such a way that you will have the time to ask questions and clarification questions. Because it is important to understand the mechanism, because we have to work with them afterwards, otherwise our workshop will be almost. So please pay attention, write us some questions, and I will make sure that we have the time to.
No pressure. Okay, good. So, first of all, to understand what do we mean by complexity, I will start. The first time the term organized complexity was mentioned, this was Warren Weaver, it was the 50s, and he was the first to say science until this century until, let's say, beginning of the 19th century, dealt with problems of simplicity, which mean few bodies, the billiard balls, the planets, and it did an incredible job. This is what brought us to the moon. Then it dealt along the end of the 19th century and the 20th century with what is called problems of disorganized complexity. Many bodies like statistics, gas, everything which is statistical. So there is some kind of average. And now, and he was in the 50s, and then eventually it happened only in the last 30 years, we are entering the place where we can start to look not only at disorganized complexity, but also situation in which we have many parts, many components, but they actually interact in a way which is interdependent, and this is what gives us the nonlinear effect that we call complexity. I'm going very quickly on this. Immediately, or more or less in the same years, it was Jane Jacobs, which I assume you all know, and she also was the first one to make this connection between cities and problems of organized complexity, in the sense that they have an incredible amount of variables, the flows, the people, the structure, the resources, but they are not random, so they cannot be studied statistically. We need to consider them interrelated and interdependent. Now the question is, what does it tell us? Does it tell us that the cities are organisms, which is part of the question that have been asked? Does it tell us that cities are chaotic? Does it tell us that there is no way to know? So to answer this question, I'm going just to give the really basic lines about systems. When we speak of complexity, we are speaking of this emergence of order. We have seen it now in the talk of Nurit when she speaks of abstract principles and codes. There is some kind of self-organization that produce a recognizable order, patterns. So we are speaking of local interaction among a very large number of components that somehow lead to organizations on the global level. So for example, you have neurons. Neurons are relatively simple units. When you put them into the very high level of interactivity which you find in neural tissue, you suddenly have emergent properties that goes from language to feeling, which were absolutely not present in the unit. So you have a kind of emergence that is non-expected while studying the parts. This is one example, but it is organisms, it is ecosystems. Basically, once we start to look at it, we realize that we are part of complex systems, and we ourselves are complex systems. We simply didn't have the tools to look at it this way, to call it this way, and this is the big change in science that happened in the last 30 years. But this is not enough, because when we speak about local interaction and global consequences, then we have many of the systems that we ourselves have generated in the last 60 years, let's say from the petrol era until today. So we are speaking about markets, and we're speaking about the web, of course, and we're speaking about infrastructure networks that as of today, they all have emergent properties, which mean we began all of these projects as kind of engineering, apart from markets, but from an engineering that it's a very linear science, we got to a place where all of the systems have emergent properties. So, what we are asking in parts is if cities can be also made part of these systems which are generated, and they are artificial, but they are complex. One way to describe this is from a very interesting paper of Yanir Bariam. It can be described as an historical progression of civilization towards higher and higher level of complexity. The way he's analyzing it as control structures. So he showed that from a place of tribal, small enclaves, it moves towards a more hierarchical and wider, and then it eventually gets to a more and more networked kind of structure. But the interesting part is that what happens also while this enlargement takes place is that there is a number of connections that did not exist initially that are multiplying themselves, and we're speaking about military, but also trade, and also travel, of course. And what I wish to show here that I find interesting is that while we move towards a growing level of complexity, we arrive to a situation where we have multiple scales. So here we have one scale, and here we have mainly one scale. And when we come to situations which are complex, we can immediately recognize a multiplicity of scales. So you have the wider system, and then you have all kinds of smaller communities until the smaller type of unit. And this brings us multiple layers. And this, which I don't have the time to go deeply into, but any kind of system which is complex, because of the multiplicity of scales and type of components, can never be described by one language. So you cannot take one particular mathematical language and describe the whole event of the system in the same fashion in which you cannot take a spatial language and describe a whole city. And I think that Jerusalem gave us the top of it. So moving from here, another way to describe it is that we can see two axes. One is about diversification, and one is about integration. So if we start from random variable, which is the statistical, many variables, but they are not connected, like tiny balls of glass or random passers-by, while we go towards diversification, which means they become more and more different, we enter the aspect of chaos. If we go by integration, we got something which is more and more coherent, like a rigid body. But when we speak of organized complexity, it's the one place where diversification and integration are happening simultaneously. And they always keep this kind of balance in which they are catching each other. For example, when we look at any kind of social organization, you can see that there is division of function, division of labor. So you have a kind of process of diversification. But this process of diversification must be accompanied by a process of integration in which the multiple functions are coordinating. Otherwise, you don't get social structure. So what we are interested in, it's not the chaos, it's not the random, and it's not the fully organized, which is the ideal of the top-down perspective that we have. It's something that deals with organized complexity. It has both. Okay, so markets in this sense give us a very good example of this, because this is the kind of place where you see it starting as if randomly, but then this random slowly organized, usually in areas that sell similar products, and after that these areas are kind of rooting down, and each market has its own dynamic to see this. Here speaking on physical markets. One more line. Organized complexity, the very strong aspect of it is that it is adaptive, which means that when you have changing conditions, it can evolve in a fashion that it can adapt, and if it can adapt, it means it can learn. So any kind of complex system can actually retain, in some fashion, past experience. And there is plenty of ways in which memory is entering in these kind of systems. It's either structure or codes or material languages or abstract languages, but there is always some kind of memory, because otherwise processing of information is not possible. One of the reasons why we find complexity really interesting, and really interesting in the context of cities, it's because complexity theories allows a kind of bridge between the individual and the collective. So you have the psychology, and you have the social, and you have the individual, and you have the city. And as it was said before by Nurit, we have this bridging happening between bottom-up, which is spontaneous and it's local, and we have the top-down. Now, what we, in the last few years, this idea of bottom-up took a bit over. So it is as if everything is self-organizing in the world. No way. Which means that it is partly self-organizing, but even without some kind of intervention, the moment the self-organization happens, you have global patterns emerging. And the global patterns operate as a top-down restriction. So you always have an ongoing negotiation between these two. The difference from the straightforward hierarchical top-down is that this connection bottom-up, top-down, it's dynamic, which means that it has some mechanics and some speeds of change that are inherent within the system. Here, it's just to show, for example, you have here the orange point would be the individual, and this is different global patterns of networks. This is a very famous diagram. Here you have a fully centralized one, so the connection between this point and other points need to pass through the center. Here you have what is called decentralized, so it can come to a closer, easier center to reach and then to move to the next one. And here it's a fully networked, which is initially flat. So you can go all kinds of ways. There is great ways to get lost. We've seen it this morning. So few examples that I am going to open very, very lightly. We are tight in time. Okay, so the first one I'm going to speak about is actually when we speak of cities and when we speak of the social aspect, what we are interested in is what I call collective coordination. Because when the order emerge, it means that there is a level of coordination that goes beyond the individual. And as of today, after many of the phenomena that we have watched taking place on the web, open source, and many other placemaking, we see when it works, it is a kind of collective behavior that is exceeding the capacity of the individual. Now, before we go to the current context, which is the human context, I'm going to a relatively simpler context, which is, for example, social insects, because there most of the computation is happening actually externally, so it's very visual, this aspect of collective coordination. So we see, do we see? We see. There are few critical steps that have to take place for collective coordination. The first one is that each individual must be able to acquire and spread information locally. Nobody needs to see the whole map in order for it to operate. In order to act, it must be enough the information that I get locally. After that, I respond, which means the individual, the unit, respond behaviorally, by behavior, which means that the acquisition of this local information is enough for the particular agent to respond behaviorally. And after that, somehow we have this huge jump in which we see the pattern at the global level. So here we have this gap that we need somehow to work out, which is how the information is traveling. This is the question. How this information is moving from something which is local to spread. Like a very good example can be the flock of birds, in which the birds see very close, relatively close, but the pattern emerge on the global shape of the flock. And here I changed the images because one of the things that by now it's quite known is that there is a very strong correlation between self-organization phenomena and environments. They are very much dependent on the particular environment. So here is, for example, ant city. This is a particular growth of bacteria, and this is one of the very old settlements. So when we speak of environment, one of the things that we find a lot in natural system is that a lot of the coordination is actually indirect, which means it does not happen in the direct communication between agents, but it happens by the way they lay marks within the environment. This is the most known example, which is the ant foraging, the way the ants organize themselves in and distribute their resources towards a different source of food. So you have two ants, they go out. When they find food, they release some kind of pheromone, it's a hormone. It is laid down on the ground, it remains as a trace, and it also evaporates. And this tension between the hormone being stronger and evaporating in time, it's all that it's needed for optimization. So what you get at the end through something which is extremely simple, it's a marker that evaporates, you get an optimization that from our standpoint to optimize this kind of equation, it's one of the problems which are most difficult to solve even with computers. But considering the environment and some very simple collective mechanism, you actually get it through the environment. So we have many examples of this kind in nature, which I'm not going now. But in the last few years, it became very clear that something very similar is happening in the digital world, where the digital is understood as a medium. It's a kind of environment where you can leave marks and traces, and it allows for this kind of collective coordination. So this has been...
What's your x-axis?
Okay.
What's written in blue?
This is written current. I will just illustrate it. You can have this kind of living traces in the environment. Can be either quantitative, like for the path of the ants. So you live more and more, and it grows towards the threshold. So you have a response that is gradual. The more action. Or it can be qualitative, which particular mark makes me change my behavior. Okay, so for example, if I make an edit on a document that I'm writing with someone else, it will make the behavior change because there is a response to the edit. And current state of the solution means that it's something that I can read directly on what I see, which means my action transform the environment. So for example, in the case of nest building, what is the information it's within the structure of the nest, where it got and what needs to be done. Or marker based, it means that I leave traces which are kind of metadata. Okay, so they can be comments or even post-it notes, or the most clear example is the likes, which from the fact that someone simply responds locally by liking, the outcome of it, because of the processing of the medium, is that you have a ranking, which means you have an ordering factor, you have a constantly changing hierarchy of filtering. Okay, so this is, for example, one of the way to describe, 5 minutes, 3 minutes? 5? Okay, so this we are jumping. Okay. This we spoke, so it can be applied to the physical environment, to the human physical environment. This is the most simple example, which is the walking path. So if it's being walked, it means it's updated. If it's not walked, it disappears. It's a kind of evaporation mechanism. We spoke before about markets, but what is important here is that actually where it was, is that this kind of mechanism works as a design engine that produces structured environment. And the structure within the environment is containing information which is critical for collective coordination. And this is the place where we need to decide if this kind of correlation can be done with the abstract code and principle, for example, that were spoken before, that belong to the urban space. Okay, so I think this 3 minutes. אוקיי, so...
רגע, את רוצה מספיק קטנה בשביל ממש חבל לי? ניקח כמה דקות קדימה? נהיה פחות נוקשים?
I think if we look at what you're telling us and we think about each of these terms, as I know you want us to do, Yara, in terms of what does this mean for the kinds of placemaking activities that we saw yesterday, each one just explodes a huge number of questions and thoughts. So I think we should take the time.
We took the time.
Okay. Okay, so here we have a different kind of mechanism which can be, I think, also extremely relevant. When we look at trees in nature, there is something which is very interesting in terms of structure, because a tree somehow deals with changing condition while being perfectly immovable. It's like it cannot change location. This is not part of its response. Not only this, it's a very expensive structure and it's a very slow responding structure. And if we look at all other systems in life, it's really difficult to understand how do they do this. Not only this, there are some that says that architecture takes a lot from trees, and I won't go there.
City is not.
A city is not a tree, by all means. So in the last 10 years, this is the research of the last 10 years, actually it was discovered that the trees are not alone in this. We have, there are mushrooms which are colonizing around 90% of the trees. Now, they were understood by us and by our science as parasites until not long ago. And what actually happens here is that the mushrooms, most of it, it's underground. It's not on the ground. Underground, it means that what they are huge networks of mycelia, and they extend for kilometers, the same plant. So what can be said is that centralized, the tree, from the standpoint of structure, it's a centralized structure. It's a centralized network. It has a very clear center, and from there it expands. The mycelium, it's not centralized. The mycelium, it's a rhizome, which means that it grows as a network and it doesn't have a center. It can both expand and retract, and when it retracts, it can digest its own material, so it's actually moving around in the form of network. Now, they actually connect at the cellular level, and they create a kind of network that, as of today, it was discovered. It was not like this. This is you see the difference. This is a pine without the mushroom, and this is a pine with the mushroom. You immediately see that there is enormous growth in the area of influence, and there is also and there is also the mycelia. It's very, very fast, which means it can grow and disappear. It can move in directions and then retract, while the tree it's very slow. So you have this combination of two networks. You have the centralized and the non-centralized. You have the slow and you have the fast. And suddenly you have structures which are incredibly dynamic. Now, what is interesting about is that one of the paradoxes in forests, they didn't understand how the small trees could grow. Because when the forest is dense, you don't have enough light for a tree to grow. So while doing these studies, it was understood that actually the big trees are feeding via the network of the mycelia the younger trees. And by that, they decide where the trees are growing, because the feeding is located. So in a way, there are patterns in structure which are influenced directly. And again, we find this aspect of multiple scales, because in order to have something which is so complex, you need to go from the interface, and the interface between these two networks is at the cellular level, and you have to go all the way to the scale of the tree, but even farther, all the way to the scale of the forest. And as of today, it is understood that this kind of systems, some of them are a few thousand years old, and they are an expanse of a few kilometers, which means they are the oldest and biggest organism on the planet. So why it's interesting for us, it's the fact that somehow this correlation between these two different types of networks, which I am doing the extrapolation, I don't know if you will agree, my extrapolation, I see the centralized more as the regulation and planning and the existing structure, and the one that is run and go, it's more a kind of R&D, experiment and explore and exploit, which mean that the aspects that has to do with tactical urbanism and placemaking, it's a kind of running of mycelium that then can provide the relevant roads, but this is, at the moment, it's a proposition. It's a very big proposition. What is interesting here...
Placemaking is mushrooms.
Mushrooms.
Placemaking is mushrooms.
Is mushrooms. No, this is not what I wanted to say. So you have novelty in the interaction between diversity, it allows coordination because it allows the passage of signals at different speeds and different scales, and it is a much better way to exploit resources. Okay, so this was concerning this. And the last one, enclosures, which this is actually came to me yesterday while going through Jerusalem and realizing that there is 1,000 cities inside one city, and you are like, what? So again, this is something that also has come under the eyes of understanding the complexity of the human bodies. Until not long ago, a body was defined genetically, which means our body is the specific genes which reproduce itself in a body. Actually, numbers-wise, bacteria are more than our cells. Not in weight, they are just a few kilos still. But in numbers, they are more. And they are extremely different genetically, and they have very different interests than us. Not only this, if it turns them, they are big killers. And we host them on a constant basis. So the question is, how does this work? How can this operate? And one of there is, yes, I am not pretending to open this in 1 minute, there is a lot, but one of the theories that is coming up has to do with enclosures, which mean you have environments that are semi-permeable, but each one allows a particular kind of different type of bacteria, and these environments are what actually allows the coexistence. So it's adjacent enclosures. This is what happens. One of the best examples for it, first of all, you needed a cell at all for life to emerge because you needed the enclosure that could be regulated. But one of the best examples is the guts, the intestine, because there we have so many different organisms, and the intestine is actually totally fractal in the way that it has continuous different environments because of the curve, because of the villi, because of the little hairs on the villi. So you have this kind of fractal surfaces that allows these enclosures to actually create the differences, but also bridge them in a fashion which is not okay. So again, after giving this very wide, simplified, sorry for these examples, we come back to how to look at cities as systems. One of the main differences is when you look at the city as a system, you don't look at the city not as a structure, not as a plan, you ask about what is dysfunction. Because if we look back in the history of civilization, cities are actually the oldest and most resilient collective behavior of the human species. So they must have a reason, which is not simply we like to build. They must have a function. This is why they exist for more than 5,000-6,000 years. So the question here becomes, what is the function of cities? And of course, do modern cities support the function in a fashion which is compatible? And what does it mean to enable urban function? Again, to know if they are complex systems, we need to see if there are global patterns. And this is the first kind of research that you do. You go to look for the global patterns. Of course, there are many global patterns. Food distribution, it's one of them. But we can look at it more deeply, both from the standpoint of behavior and from the standpoint of structure. So from the standpoint of behavior, we have two main trends. One, it's called the economy of scale, which means that you have an exponential diminishment in infrastructure use when you have growing town. The more the cities grow in size, the less infrastructure, the less per capita water, the less per capita gasoline it's being consumed. And this is a study that was done on a very high number of cities, and the behavior is consistent. So not only its economy of scales, it is also exactly on the same line in which economy of scale happens in organism, which means that if you take a mouse and if you take a whale, the metabolism of the whale is much slower, so that it's incredibly more efficient, and it grows with size. So the mouse has a heart that needs to beat incredibly fast, and the whale has a beat which is much, much slower. And the proportion between the growth in size and the growth in food, it's not linear. It is exponentially diminishing. And this goes all the way up to forest, and it looks that cities stand on the same kind of line. So this was the first study that raised the question, is the city an organism? Which I don't want to go there, I don't think, but the one thing that it makes us reflect upon before we rush to call it an organism, that it might be nevertheless some kind of living tissue. Living tissue in this sense being an embodiment of the physiology of us, of the species. In the same fashion in which the nests of social insects provide physiology. The other very interesting behavior is the fact that you have an even stronger exponential growth when it goes to the way that productivity, which is they measure the number of patents, income and life rhythm, goes up again with city size, together with crime and stress, and of course. But it's also very consistent. And the theory that was proposed here by Bettencourt and West is that actually city may work as social accelerators, in the sense that they provide the interface and the multiple scales of the interface. But if this is the case, then they are fundamentally dependent on networks and the structure of networks, and how many scales these networks are covering. So if we have only very wide and fast ways of communication, we lose texture in the networks. And there is a lot to say there, but I'm not going there. This is a different type of patterns which I also find very interesting. This is morphological patterns. So this is a study that was done by Burdick in the group of Salingaros. They studied 3 old cities. One of them is Paris, which is this one. And they studied distribution in space. Here it's of accessibility to parks, big parks and small parks. But they did the same also distribution in sizes of roads and of block size. And what can be seen is that actually the distribution, again, it's an exponential in which you have very few very big parks, but then you have an extremely long tail of small parks, which actually allows accessibility for everybody. Now, when we see this kind of exponentials, we also know that fractals are involved, because usually fractal structures produce exponential behaviors. And this is what I spoke of before. This is Salingaros, which I think shows in a quite insightful hand sketch. What does it mean that we speak of networks that have structure of exchange? Now, if the city is a social accelerator, the structure of exchange must be at the human level, because this is the interface. The interface, like in the trees and the mushroom, it's the cell. And in the city, the cell is the human level. So what he is discussing here is that it doesn't matter how wide is the scale of a city, monumental, whatever, it must have somehow these enclosures where the exchange is at the human level. And here we're speaking about public transport, public place, public interaction, and of course, everything that deals with community dynamics, placemaking. It's actually recreating this part of the tissue of interaction, which can be discussed how much it went lost in some of the modern built environment. זהו, גמרתי, ירה. Okay. So to finish is that, to put it really in a line, is complexity in city tells us it is impossible to know and to plan a priori, at least not to the final details. You can do something that deals with the very wide description of a place, exactly like Nurit was showing before concerning the difference in regulation and laws. But because this is the case, the one way we have to understand this the way to propose this regulation has to do with the necessity to probe a system and prototype within a system. Probing, it's like when you don't know a system, you start to do very small experiments and you see how it reacts. So we're speaking of probing and prototyping, and I think that if placemaking can be in some way connected to this and some form of monitoring can be generated for it and recorded for it, then we have a huge tool of not only of creating the space and the place, but of understanding and abstracting that into the theory. We need this design for spontaneous collective coordination. It's a must. Also to understand what are the relevant dynamics, and the possibility to relate to cities as embodied physiology, which becomes much more tangible when the community is involved and we don't only look at streets and buildings. Thank you.
First, thank you for the lecture. It was really interesting. I wondered if you can speak a bit as to the politics, the role of politics in these types of systems. You talked a bit about the value of communication, but how does one envision a value or like some sort of a shared value for the system? How do we create social justice or stuff that we want to see in our cities through these types of systems?
Okay. When you have, I will relate to it from the standpoint systematically, not, I'm not giving the ethical kind of response. If you have a network, it usually creates its places of attraction, which we can be read as values. And I think that what we want to understand is how to influence this convergence within the network towards values that are relevant for us. This is also why we speak of probing and exploring, and you also want it to happen in a fashion which is very diverse. You cannot, we are not, when you have a complex system, it never has one language, it never has one set of values in these terms. You have to allow the diversity of it, but we want to understand what does it mean to support a set of values that are relevant and I think we are in a historical era which is screaming for it, yes, because we are very diverse and in a very big clash of values, and truth does not work. So it's about understanding the influencing factor, and part of it, there is a lot of exploration, because it's like we come from an historical perspective that look at values as given from above. And then all what you're left with is to take this value and enforce them well enough, good enough, beautiful enough. And here we are speaking about values emerging within the system in a fashion that match the system, but still we also wish to recognize ourselves within it, so we need to find ways to interact with it, to influence it in some fashion. That's as far as I can go.
Other questions?
Please.
You talked about the human scale, the human as the cell in the body. And I've been struggling with the thought that cities are definitely man-built and man-organized, and an extension of the human race. There was this Facebook post that was running all over the place about how reintroducing wolves into an ecosystem changed the entire ecosystem. I'm asking myself the question.
It's a very good question. It's a very good question, and it's also very correlated, because we don't, it's also what I said before, it's not that bottom up, it's automatically fantastic. Bottom up can go to really horrible places. It's enough to look at history to see where bottom up can go. So the question here, it's not bottom up, the question here is for us to understand what is the relevant dynamics between bottom up, top down. We have it happening in markets somewhere, the gap, the social gap. It's a totally complex system, bottom-up organization phenomena. But it doesn't mean that we need not to intervene. The whole question is intervention top-down may probably create catastrophe and not necessarily yield what we are looking for. We need to re-understand how to interact with the system. And in this sense, the local probing and prototyping can provide us with a lot of information, which currently we don't have from the huge theories, though yes, the important part of complexity is also all the work which is being done on mathematical models and simulations are becoming more and more relevant. But what I'm speaking here, it's instead of relying directly on a simulation that we cannot really open and unpack, unless you are a very good, extremely good mathematician, to understand also what is the approach and what are the principles that at least can help reframe the thinking about it, and can help us put it in place at the human scale. The simulation, again, does not really work at the human scale. Simulation works on global patterns.
I've heard this lecture, I think, a couple of times, but it's always a little different. I think what I take from it, most of it is think like a mushroom.
No, but you didn't hear mushrooms from me before?
No, that's what I'm saying. This was new to me. Because I think in many ways a lot of the complexity science is trying to understand complexity in a way that will enable us to control it, which is in a sense applying to complexity the same kind of thinking, which is basically the hierarchical network, the hierarchical thinking. If we understand global climate change, we know we have huge, great models, we will be able to control it. Baloney, we will not be able to control it. So I think we are mushrooms in this, each one of us, we are the mushrooms. And we have to think like the mushrooms. We have to think locally, but understand that our local environment is influenced by the trees outside. But we are mushrooms. This is what I'm thinking.
Okay.
So, in response a little bit, maybe instead of control, influence, and then I think basically what you say is the entry point for influencing is feeding information into the interface at certain points. So creating the marking that more ends will follow and strengthening or inducing certain emergent
At the
behavior, if
moment,
you already
this
see.
is the place where it's easier to intervene. It doesn't mean that this is, but it's definitely the place where it's more relevant to explore and intervene.
Can I ask? It's because what I kept thinking about in the last part of your lecture was the question of cultural diversity, especially since you started talking about cities. What is the function of cities? Which for me, my definition was, they support, they're the infrastructure for human culture, and this reflects both ways because the shape of the city basically usually reflects the cultural values of the people who constructed it. Unless you have a top-down interference.
But it's more than this. What I was opening here, it's not that the shape of the city reflects the culture, it's that the shape of the city is a very big part of the culture. And if you destroy it, you lose critical information that is embedded.
Mm-hmm.
So you can either operate on the if change happens, either you operate on the culture, but change happens also if you operate on the structure.